Okay, now that we oriented ourselves with the broad concept of the climate system and Earth system, let's dig a little bit more specifically into weather and climate. Most of you already have a good sense of what is weather and what is climate. For example, I am recording this course here on 16th November sitting in Mumbai. You would know that if you are from Mumbai, 16th November tends to be warm during the day with the slightly dry air probably coming from the northeast because it's the end of the monsoon and we are in the so-called northeast monsoon. Humidity is lower than, let's say, 16th May, for example. So May is also dry typically on the 16th. November is also dry. May is probably a little bit hotter, but maybe same temperature, but it is much more humid, so it feels hotter, and November is typically drier. That's weather on a given day, what you expect or what you get, and it may turn out that in a particular year like 2021 is a La Nina year. We don't know what La Nina is, don't worry about it. Something that happens in the Pacific that can influence what kind of temperatures happen over India during November, December, for example. So for some reason, November 16th of a particular year may be much colder than what you expect or much warmer. So weather is what you actually get on any given day, and climate is what you expect. So as somebody who knows November as drier month than May, you may expect the climate to be milder in November in terms of humidity at least, but for particular reasons the weather may turn out to be just as humid or even more humid than May 16th. So weather is basically what you get and climate is what you expect based on your experience of multiple November 16ths. You will expect November 16th to be a certain way, which is what climate is, and instead you will get something which is what weather is. Okay, long story short, if we look at data for a particular place, this is weather data from Corvallis for January 2017. So we are looking at January through February, and Corvallis is typically cool, so you are looking at degree Fahrenheit, which is what America uses, but here we are with degree centigrade, which most of the rest of the world is used. So you can see that the temperatures barely get above 10 degrees centigrade, which is pretty cool for a country like India, for example. And there is also dew point shown here, which is a measure of how humid it is. For example, there is a place here where the temperature is high, but the dew point is low. So you can add moisture to make the dew point rise, and so on and so forth. So you can see that the temperatures are wobbling around even within a day. For example, here 13th November to 13th January to 14th January, it gets warm during the day, cools down at night, warms during the day. So you have a strong diurnal cycle, and there are also lower frequency variabilities. So you can see that the barometric pressure gives you a sense. So here you are looking at hectopascals or in inches of mercury that in the barometer. So you expect that when the pressure drops, there is some sort of a storm coming in, so it's probably bringing moisture and there is a temperature there. And when it is high pressure, in this you have two high pressures, one here and one here, and you see certain different characteristics because high pressure is typically associated with no cloudiness, lower humidity here, so you can see, so you get weather that is more stable, whereas stormy weather comes with lower pressures. Okay, so low pressure typically means stormy weather, so you have warmer temperatures, more humidity, and so on. So you can also see wind speeds, low pressure, high pressure, so the low pressure storm here has got wind gusts that are pretty strong compared to the other days. The other days don't have much wind gusts, so you can see here temperatures wobbling around, high humidity and wind gusts. So this is kind of telling you that weather is combination of temperature, humidity, winds, pressure and so on at a very local scale, but obviously temperature has a certain scale, pressure has a certain scale, humidity has a certain scale, winds have a certain scale in space, for example. Okay, for example, temperatures can change rapidly in the atmosphere, whereas they cannot change so rapidly in the ocean, because ocean is a fluid that has a high heat capacity compared to air. So you can imagine a pot that is on the stove. The pot gets warm slowly compared to the water, fast compared to the water, because the metal has a low heat capacity. As soon as it gets heated, it begins to warm. Water takes time, and when you turn off the stove, the metal pan cools down fast, whereas the water cools down much more slowly, and so on. So here is local weather data, again looking at daily minimum and maximum temperatures and daily precipitation from Corvallis from 2012 to 2016. So now we are looking at multiple years. Now you begin to see more features. So you can see that there is weather. So there is these high frequency changes in temperature, and there are spikes in rainfall. So you can see that temperature is much more continuous, whereas rain can be zero during certain times, and you can have spikes of rain during certain times. And typically here cooler temperatures are associated with rain in each year. So winter storms bring rain and snow in the mountains, rain on the lower levels and snow in the mountains. Summer gets warmer than winter, as you expect, so you are now adding a seasonal cycle to the monthly data we saw before. So we are now getting to see seasons, so summer season, winter season. And you can see not every year is the same in temperature, so there are year-to-year variabilities. So we have to average weather data over many years to get climate. So when you think of how November 16 should feel, you have averaged mentally many November 16s in your head through your experience and say, I expect November 16 to be a certain way in Corvallis or in Mumbai or elsewhere. So again, weather is what you get and climate is what you expect. So how many years do we have to average? Well, there is no fixed number. Typically we say 30 years, but one has to be careful. Climate or the average weather may change even in 10 years depending on where you are. Okay, so that begins to give you a sense of weather and climate. So now we are looking at longer time data, 1971 to 2000 as 30-year averages. So now you are seeing maximum temperature during the year, average temperature, so minimum temperature in blue, average temperature obviously is in the middle, so summer is warmer than winter as you expect, and precipitation is low during the summer months and high during the winter months. Okay, this is in Corvallis. Obviously in India and Mumbai, rain is very heavy during the summer months, and it basically doesn't rain during the winter and spring, fall months. Okay, all the rain tends to happen from June to September. Okay, things change because of climate change, which we haven't defined yet. And we always look for statistical properties based on such long-term data. Why? Because we want to see how the statistics of weather and climate are changing and what is causing those changes. Is it something natural like the El Nino and the La Nina I mentioned, or is it something like increased greenhouse gases that humans are introducing? So for that we look for number of occurrences or frequency of temperature at Corvallis on May 1st, a particular day. So it has a few number of days where temperature is in the 40 to 45 degree Fahrenheit range, and very few days where it gets very warm up to 65 and 70 degree Fahrenheit. The largest number of occurrences happens in the 50 to 55 degree Fahrenheit range, so this is what you tend to remember as climate. If you experienced many May 1sts in Corvallis, you will tend to think, I expect temperature range of 50 to 55, which is climate, but you may get 65 to 70 on a particular May 1st, very rare, so that's weather. Some rare occasions you may get colder temperatures at 40 to 45 degree Fahrenheit and so on. So let me stop this podcast here and then come to the concept of forecasting. We also need statistics, because when we make weather forecast, typically we do say what temperature we expect the next day, but oftentimes we may also say it'll be warmer than normal, precipitation has a 30% chance or a 50% chance, and so on and so forth. So we may give probabilities of what may come, especially for longer periods. For example, if we are in September, then typically you will see forecasts from NOAA, National Oceanic and Atmospheric Administration, or the India Meteorology Department, that says this winter will be colder because there is a La Nina happening, or it will be stormier over Oregon because there is a La Nina happening, and so on and so forth. Okay, so that's briefly weather and climate. We will touch on weather prediction and climate prediction. It's too early in the course, but we will just listen to it, get a sense of it, and then we'll get into the details of the data, the processes, and other things that are more the introduction to climate science. Okay?